All right, can everybody hear me all right? I actually don't know how you'll tell me if you can hear me. Is there a mod in here? Is there anybody out there? Okay, if there's somebody out there that can hear me, there we go. I was gonna say type a. Okay, thank you, Floyd. I was gonna say type in the Q&A. All right, perfect. All right, well, why don't we get started? Hey, everybody, welcome to this session, this breakout session. My name is Patrick Druley. I am a senior solution engineer at Confluent. If you're not familiar with Confluent, our co-founders are the co-creators of this little thing that we're going to talk about today called Apache Kafka. So that's going to be what this thing's all about, and it's really going to be about some things that I've learned over the years, things that some folks may not know, but I think that they definitely should. So hopefully it'll be for everybody, for new folks to Apache Kafka, for folks who've been using it for a little while. I tried to sprinkle in a little bit for everyone because I knew we were going to have a nice, wide, broad audience today. So before we get going too far, let me kick off this poll because I kind of wanted to see where everybody was at with their experience. So I'm going to see if this works and launch this poll. All right, so now there should be a poll. And if everybody could just tell me how much experience you've had with Apache Kafka. You know, don't feel any pressure. Just give me an idea where we're at, and anybody over 3 years, I'll be really impressed. You'll definitely really impress me. So let's see. Let me check the Q&A. Yeah, chat. Yeah, chat. Oh, and while you're filling out the poll, the chat is disabled. We can enable it if y'all really want it. But if you have questions, uh, if you have questions, just put them in the Q&A and I'll answer them as we go. So I'm happy to do that. I definitely want this session to be interactive. I hope you get that from all this good stuff. But yeah, put your questions in there, and I will ignore that phone call, and I'll close this poll. And I'm just answering. Yep, all good. All right, I'm just closing up these questions. All right, let's end this poll. All right, so the poll says we've got, okay, so we got 15% newbies. That's good. We've got 31% that have less than a year experience, 36% that have 1 to 3 years, and then another almost 16%, 15% with over 3 years. So pretty good range. I mean, you can kind of see where the graph is here, right? The curve's kind of in that 1 to 3 year range. So awesome. So hopefully you all learn a ton here. All right, let's get going. So if you are new to Apache Kafka, if you haven't heard of it before, it's this really cool thing. And one of the things that I like to make sure people understand is that Apache Kafka, it is a project governed by the Apache Software Foundation, but within that project, there's actually several different components. There is, of course, like the Kafka brokers, which is what everybody thinks of when they think of Apache Kafka. They think of Kafka brokers, Kafka clusters, which are really cool and can be exciting. But there's a whole nother side to Kafka. In fact, the majority of software that is out there that is Kafka related software is actually client software. It's actually Kafka clients that make up the ecosystem when we think about Apache Kafka. And this is there's a core Java library that kind of comes with Apache Kafka. There's some other libraries that different language developers have written. And then there's these very like specialized and sometimes forgotten libraries that are a part of Apache Kafka. In particular, what I'm going to tell you about are Kafka Connect and Kafka Streams. So Kafka Connect is a really cool framework for getting data in and out of Kafka. So we live in a world that if you've been listening to some of the sessions today, you realize that there's a lot of technology out there, and not all of it originates or ends in Kafka. It just kind of sometimes hits Kafka, and so to get it to Kafka, we can use Kafka Connect and build connectors to get data from a source system into a Kafka topic, and then maybe send that data downstream to some target system. This is a very classic use case for doing change data capture on a database, having that run through Kafka, and then outputting that to your data science or data lake or Hadoop platform of choice as your sink, right? So we have sources and sinks on either side of our Kafka Connect pieces. In the middle, there's another component that we have called Kafka Streams. Now, in a traditional ETL pipeline, you would have your extract, right, and your load. That's Kafka Connect. And in the middle, you have your transformations. And that's the piece that Kafka Streams provide, is that transformation layer to allow you to do enrichment, to allow you to do aggregations, filters, all the kind of cool stuff that we think of when we think of something like stream processing. That is what is provided by Kafka Streams. And it is just a Java library that you can implement within your own application, or you can build your own kind of dedicated Kafka Streams application. So we now know, and I think everybody should know, it's made up of several components. So now the next question becomes, like, what is it for, right? And I really think it's important to make sure that everybody knows that it wasn't really designed, it wasn't designed for just messaging. In fact, it was kind of purposely designed for this thing we call event streaming. And event streaming, has a lot going on, right? It has actually borrowed the semantics from kind of traditional messaging systems. So if you've ever done anything with a message queue, you should be familiar with the publish and subscribe semantics, right? We publish a message, we can subscribe to that message. Very similar semantics with event streaming. We're just publishing and subscribing to streams of events. And there's a slight difference between an event and a message. I like to make it easy and say, like, a message can be kind of anything. An event is something that has definitely happened. And usually in our context is going to be something that has happened either in the real world or something that the machine has done, right? If you think of in the IoT space, maybe. The second thing that your event streaming platform has to be able to do is store these streams of events, right? And when we talk about storage, we're talking about disk. So this is actually persisting these events to a file system on a disk. There's nothing ephemeral about this. This is a true kind of persistence layer for an event log or an event stream. And that's good because we need that persistence in our environment, because the applications themselves may not provide it for us, or we may want to provide persistence to act as a buffer for our analytics ingest pipeline, or maybe we want persistence because if we have to go back and look at events that have already happened, we want to go back a certain amount of time, and we can define that retention in our event stream. And last but not least, we also need to be able to process and analyze these event streams. And that kind of ties into the Kafka Streams component that I mentioned earlier. But there's several frameworks available out there in the ecosystem, your Kafka Streams, your Flink, your Spark Structured Streaming. If you've ever heard of something called KSQLDB, Confluent does a little of that with KSQLDB. So there's lots of different stream processing frameworks. and they can be used as part of this event streaming platform to do some very highly specialized and important analytics or analysis or processing on them. All right, everybody with me so far? Anything going on in the Q&A? Nope. All right. Good. Is chat enabled now? No, still off. Okay. If you have questions, pop them in the Q&A. All right. Next. So this is a artist rendition of me playing Valheim, and for those of you who've never heard of Valheim, I feel sorry for you. But if you have, you'll know that it's important to understand that in Kafka land or in the Apache Kafka ecosystem, topics are for humans, for us humans, right? They're logical constructs. Partitions are the physical constructs that are for Kafka. So topics are logical, partitions are physical, and the idea that at some point we have to be able to understand both is important. So if you're a developer, you're going to do things like produce to a topic or subscribe to a topic, and in your code, that's pretty much all you're going to have to do. But if you're trying to troubleshoot, or you're trying to debug, or you're trying to understand why the performance isn't working as expected, you're going to need to learn some Kafka speak, right? You're going to need to learn about partitions. You're going to need to make sure, in particular, that you have enough partitions, because the partitions, the logical pieces of this, are the actual unit of parallelism within Kafka. So if I don't have enough partitions, I can't saturate my clients, and I'm not going to be able to get the throughput or the performance or the latency measures that I'm looking for. Yeah, that's a fun question. Floyd said, I think he grew his beard in the time he saved, not shaving while playing Valheim. That is, I'm answering that one live. That is absolutely correct. Why is it not letting me do anything? Okay, that's weird. Because I have to actually, so I'm just going to type in yes. All right. Why can't why won't that show as answered? Okay, anyways. Oh, what did I do? Oh, I messed up the Q&A. Okay. So Kafka thinks of everything in partitions. There's actually even a lower level piece to this that I'm not going to really go into, called segments, and that's for your admins. But definitely, as if you're a client-side developer, partitions are going to be important to understanding kind of the overall dynamics of how you interact with Kafka. I will say that a lot of times people ask me how many partitions is the right amount of partitions for me, and I like to say it depends, because I'm a good little consultant. But it really is important that you test and validate in this particular arena, where you want to start. Usually, I like to give the heuristic that you want to start with the number of brokers, right? So if you have 3 brokers, which is a minimum config, it's okay to start with 3 partitions and go up from there. And there's other kind of caveats with changing the number of partitions if you're doing things with keyed messages, and we won't get into that. But you need to be able to speak a little bit of Kafka's language to kind of get through some of the debug and troubleshooting things that may come up. Okay, so that's something you should know. Where's the next? How do I scroll down? Here we go. All right. The next thing, this is really important. I guess they're all really important, but this one, this is my mantra, right? Kafka clients have metrics too, because I imagine this scenario. In fact, I don't have to imagine. I see this scenario played out every day, where you're running your Kafka client and something isn't working right, and you reach out to your Kafka SRE team, and they say, hey, something's not right. I think it's Kafka. And they look at their metrics, their monitoring, and they go, no, the Kafka cluster is fine. It's your client, right? And you go, well, my client, I don't know what's going on in my client. we're all just trying to solve this problem, but we don't have the visibility into what's going in on the client side to actually fix it. So the number one way, if we're talking about data ops, right? The number one way to improve the operations with these event streaming platforms is to make sure that your clients have instrumentation for metrics, right? So in the Java client in particular, there's for those familiar with the Java client, you'll know the acronym JMX. You may not know what it stood for until now, but it stands for the Java Management Extensions, right? And then the JMX metrics are going to be available to you to extract and actually pipe into your monitoring stack, whatever that may be, whether it's a Prometheus Grafana stack or Jaluka, Dracala, or whatever it is. Like, you can pump those JMX metrics in there. Some of the other clients don't have as an elegant a solution as JMX, but have other ways to do this sort of thing. So the bottom line is always, always, always try and have instrumentation for your clients in terms of metrics. And I haven't mentioned logs, but if you can get the logs, that's good too. So log aggregation on the client side is definitely something you can do as well. And what I've also done here is a little takeaway, and I should have mentioned up front, but this deck is available to download from the session. So it's in PDF form. You can download it. You can take it home and print it out and give it to your children. But I've highlighted kind of like my top 4 producer metrics and top 4 consumer metrics. So on the producer side, very obvious things like the record rate and retry rate, because if you're generating a lot of errors, you probably have something bad going on, right? So if you have a high rate of errors, you definitely want to investigate. If you have a high amount of retries, that could be transient network issues, or it could be, some other, lots of different things, right? Definitely an investigation if you see retries going on at a high rate. Another one is request latency. So latency, and in fact, I should definitely mention that Kafka is very network sensitive because there's a lot of interaction between the client and the server going over a network. So latencies and network performance are going to be very important to the overall performance of the system. Should be nothing novel there, but when you see kind of your request latency go up, you know that you might have potentially a network thing going on. And then on both sides, you want to look at if you're being throttled. So Kafka actually has quotas that can be managed, and they will essentially send back information that they're being throttled to the producer, and the producer can measure this amount of throttling that's going on their side. So, it's good to know if you're being throttled. It may be fine. You may not actually need to take act. You may not do anything about it, but you just might want to know that it's going on. And then on the consumer side, really all of these consumer metrics are kind of telling you similar things. Obviously, the fetch latency we kind of talked a little bit about, but both the rebalance rate and the records lag. One of the things that consumers do is they can drop in and out of groups, and when they do that, they rebalance to reassign those partitions. Remember those things we talked about earlier that live inside topics? And when that happens, if you do that too much, you're just not going to be able to consume fast enough, right? So we want to look for those high rebalance rates. Okay, I'm going to speed it up a little bit here. So another important thing to know about Apache Kafka is that it's actually been backwards compatible for a while now, and there's kind of this back and forth between adding new features and keeping compatibility. Because if you're doing something with Apache Kafka or with Kafka that's like, trying to make it the central nervous system of your business, you're going to want to make sure it's going to be sustainable and is not going to break, every single year, right? If you're building clients that are using this API, in general, they should be, fairly backwards compatible as much as possible, right? And that's the trade-off here is when we introduce new features, we're always trying to make sure that we balance that with making sure it's compatible. And the way that Apache Kafka, or the way that Kafka manages that balance, is via the Kafka Improvement Proposal process, or better known as KIPS. And you can actually, it's all publicly available information. You can go to that website address mentioned here on the slide, and you can see all of the KIPs that have been accepted. There's KIPs that have been dismissed, rejected, and they go through this process of making sure that any new feature, or any change to the public interface is going to be either non-breaking, right, or if breaking, justified, right, in some way. So it makes sure that there's not, this process makes sure there's not a lot of rework and not a lot of breaking changes with this very important thing that people are really building highly sophisticated pipelines on. So that's a big piece of it. Okay, I'm going to take a quick break because I see there is a question. So Floyd asks, how does Kafka pipelining relate to Kafka streaming? Which is most used and what's underused? How much of modern data stack can be replaced with Kafka? Okay, so I'm gonna take a quick answer to that, and then I think some of what I'm gonna go into next will also answer that. So streaming, pipelining are kind of interchangeable, so there's not much there as far as the terminology and the semantics of the terminology. If you're using the Kafka API, you're using the Kafka API. What you do with the events, whether you're producing them or reading them, is kind of up to your client. And there's kind of different ways to use Kafka, but in general, it's the same API. So the way you use it is really up to you. But as far as answering how much of the modern data stack can just be replaced with Kafka, the answer is not all of it, right? So for instance, let me give you a really good example. People like to say, like, is Kafka a database, or what aspects of a database live within Kafka? And there are definitely overlapping concepts. But if you try to take a application that sits on top of an Oracle database or even a Postgres database and just swap that with Kafka, you're going to find that that's not as easily portable as you might imagine or want it to be, and it's not going to work the way you expect. And the going from a batch context to a streaming context takes some sort of interchange, right? So like if you want to, write data out into a batch system like an object store or a HDFS based system, like you can do that from Kafka, and vice versa. You can saturate a Kafka topic from any of those batch systems. But they serve different purposes, right? Ad hoc analytics, batch analytics is not going to be the strong suit for Kafka. Now, how that relays into my next section here is that for a while people have been talking about this Lambda architecture concept. So I've tried to be cute here with my title, but that the Lambda architecture, pretty tried and true. I mean, it's heavily used in many enterprises and many companies and many pipelines today. I'm going to show you an example in a second. But you take your input of events from Kafka, you do stream processing on one layer, you do batch processing on another layer, you put those in two different tables, and your app can query the appropriate table for the type of query. That works pretty well. It's pretty efficient. It's a little bit more complex than maybe it needs to be. And so one of the Confluent co-founders and co-creators of Apache Kafka came up with this idea of the Kappa architecture, which is really just a variation on Lambda. And Jay Krebs, who I'm talking about, even says like maybe it's not that much more. Maybe it doesn't even necessitate its own Greek letter, but the idea here is what we're gaining that does batch processing or historical processing versus real-time processing. It's the same code, it's the same system. The only thing I'm changing is the amount of history I'm pushing through it, right? And we know, maybe we don't, but we should know we have that durable event store in Kafka, right? So I can keep whatever retention of events I want, and I can always go back and replay those events through my stream processing system. So in this Kappa architecture, the only difference between uh, the real-time table and the historical table, right, is which version I want to see. And if I need to, in this case, what we're trying to illustrate and theoretically would be reprocessing because I have some new analytic or derived analytic that I want to provide my application, and I can just replay those events, rematerialize that table in my serving database, and then I just migrate the application over to that other table when I'm ready. So it's not about being more efficient. It's really about simplifying the stream processing architecture itself. And I hope that answered that question. So those were kind of theoretical drawings. What I wanted to show you was an actual practical drawing of somebody actually doing this. And this is a public presentation. I pulled this slide directly. I totally stole this slide from Henry Kai, who works at Pinterest, and did a great talk at Kafka Summit in 2008 about what they've been doing since 2016. Which fun year. So 2016, they were taking database snapshots and trying to propagate that into S3 and doing all this kind of impedance mismatch between batch and real time, and it was a lot of work and a lot of strain. And what they ended up implementing in 2018, or sometime in between those years, was this database Kafka bridge, which is more of that change data capture flow where they're capturing events off the database, feeding those events into Kafka, and then using some other tooling to essentially reconcile those between their real-time consumers and kind of their batch analytics portfolio. So this is definitely a case where it's not as black and white as whether you're doing Lambda or Kappa. There's always states in between, and so they're kind of getting the best of both worlds, where they have some jobs, some pipelines that need and use real-time events, and some pipelines that just need the materialization of those events in a historical context, right? And they're able to differentiate those very easily, but it's all being fed off of the same Kafka kind of ingestion stream. So really practical example. I highly recommend checking out that presentation, let alone there's tons of other content available from the Kafka Summit talks. So with that, I believe I'm coming up on time here. Let me see. I don't see a bunch of other Q&A, but I wanted to show everybody that, or tell everybody that if you want to learn more about Kafka, if you want to see some code, if you want to watch videos of other people that aren't me talk about this in a much more elegant way, then I highly recommend checking out developer.confluent.io. Lots of resources and assets to check out at that site. And go down. If you want to check me out, I'm on LinkedIn. I do post stuff to Twitter occasionally. You can also email me if you're that kind of person. And I definitely recommend checking out some of Confluent's assets and resources. We do meetups, we do blogs. We have an awesome community on Slack for some real-time interaction. So if there's no other questions, let me see here. I'm just going to dismiss it. Is there any other question? No other questions? Am I out of time? Is there anyone still on here? No other questions? All right, I'm going to wait a minute. I'm going to just sit here. We're going to sit here for a minute while I wait for a question. No, I'm not going to do that. I hope everybody enjoyed this session. You can download the slides, like I said, and yeah, just be safe and be strong. All right. All right, I'm going to stop the broadcast. See everybody. Thank you. Oh wait. Okay, hold on. There was a question. Ah. I was hitting the button. All right. So one quick question here. How do I hold on? So one question from Wayne: How to scale Kafka streams? Okay, yeah, let's talk about that real quick. I can do that in a minute, and then I'll end it. So if you're still on, Wayne, you scale Kafka streams by making sure you have enough partitions. Is step one, and then you just have multiple instances of your application. So if you're doing some fancy stuff with Kubernetes, you could have multiple pods running the same application. But the same thing would apply if you're just having multiple VMs running the same instance of that application. And essentially what happens is as long as those streams applications have the same group ID, they will get assigned a subset of partitions from that particular topic that they subscribe to, and they will distribute the workload by splitting up the partitions between the different instances. So it's all built into kind of the underlying protocols for how Kafka does parallelism. All right. And with that, I'm going to end it. I appreciate everybody for hanging out, and see you next time.